Hi students, this is Mr. Yao. In this lesson, we are going to continue to learn more about projectile. First, let's see if you still remember what we have learned yesterday. Please try to fill out the notes without looking back to yesterday's notes. We had two different formulas, and based on the different units we may use, here they are. h of t equals negative 16t squared plus v sub 0t plus h sub 0. Or we can change negative 16 to negative 4.9, which means that would be in meters. And again, these two numbers, negative 16 comes from 32 feet per second squared, which is your gravitational acceleration. And this comes from 9.8 meter per second squared. And that's also your gravitational acceleration. It's just they are different units. So technically, if you change from feet, which means you're going to multiply this number by 12, which changes that to inches, and then times it by 2.54, which is going to change it into centimeter, and then divided by 100, because centimeter into meter, we're going to need to divide by 100. That should actually give you 9.8. Okay, h of t is height at time t, because typically we're going to find, at like 2 seconds, what is the height? Or time typically is in seconds, because projectile happens pretty quickly. Or h sub 0 is the initial height. That means where we are starting to launch something or throw something away. V sub 0 is the initial velocity. But when it's launching upward, it's positive velocity. And when it's launching downward, it's a negative velocity. And two more things. To find the height after a certain time, well, that means you are given a time. In order to find the height, you are just going to plug in the time. And to find when it is at a certain height, well, this time that means not just at 0, but think about it. At a certain height or 0, they kind of mean the same thing. On the ground, when it falls down to the ground, it just means, when it's at a height of 0. So in this case, it might just be, say, at a height of 2 meters. So you're just going to be set the function to the height and then solve the equation to find the time. So now let's have a look at some more examples. Example 1. The ball is thrown downward with an initial velocity of 10 feet per second from a height of 100 feet. What is the height of the ball after 2 seconds? So let's set it up. Not f of t, actually h of t, that equals to negative, it's still going to be projectile, so it's still going to be negative. In this case, it's feet per second, so it's negative 16t squared. Initial velocity is 10 feet per second, but it's downward, so it's going to be minus 10t, and the height is plus 100. And it's asking you to find after 2 seconds. So we're going to plug in 2. So negative 16 times 2 squared minus 10 times 2 plus 100. And it's going to be negative 64 at the beginning, minus 20 plus 100. So it's negative 64 plus 100, which is 16 feet. So after 2 seconds, the height of the ball is at 16 feet. That's example 1. Example 2. A toy rocket is launched upward at 20.5 meters per second. Launching upward, so the velocity is going to be positive. And it's meter per second, which means we're using negative 4.9. So let's set it up first. h of t equals negative 4.9 t squared plus 20.5 t plus 60.3, and that's the height, that's the meters, that's 60.3 meters tall platform, which means that's our initial height. The first question is, when does the rocket hit the ground? So it's hit the ground, which means we're going to set it equal to 0, negative 4.9 t squared plus 25.5 t plus 60.3 equal to 0. Let's solve the equation. For this one, we're going to have to use the quadratic formula. So t equals negative b, which is negative 20.5, plus minus b squared is 20.5 squared, minus 4ac, my a is a negative 4.9, my c is a 60.3. So I'm putting all of them inside parentheses. All over 2a, my a is a negative 4.9. So that's going to give us negative 25.5 plus minus, inside the square root, 20.5 squared, then is actually a plus 4.4.9. 4 times 4.9 times 60.3, that's 1602.13 all over negative 4.9. So you're going to have two different answers. When it's addition, you're going to get a negative 1.992 second. And when it's subtraction, you're going to get a 6.176 second. And clearly, the negative time does not make sense. So 6.176 second is our final answer. And that also corresponds with what we have learned in the last lesson, the second x-intercept. So the first x-intercept is at negative. The second one is right here at 6.176 second. There you go. Next, what is the height of the rocket after 20 seconds? That means you're plugging in 20. So h of 20, that is negative 4.9 times 20 squared plus 20.5 times 20 plus 60.3. And get a negative 4.9 times 400, and then it's plus 410 plus 60.3. The first part is going to be a pretty big number. So the final answer is negative 1489.7 meter. Well, the issue is, it doesn't make much sense. You're throwing something from a 60.3 meter tall platform. Unless it says you're throwing it off a cliff, well, how can we actually have negative 1,489.7 meters? That would be, well, the rocket is actually in the ground. So technically, if it doesn't specify, even after 20 seconds, height would actually be at 0 meters. Because it wouldn't make sense if it's actually digging into the ground. Typically, when it falls onto the ground, it just stops there. So in 20 seconds, it's going to be 0 meters. Again, unless it specifies it's throwing off a very tall cliff. Okay, next. Example 3. An object is thrown upward at a speed of 95 feet per second. Well, you can see the function is actually given. How high is the machine off the ground? Well, the c, well, off the ground, that means the c in standard form, because that is the initial height, which is actually 2. Don't forget a unit. Then the question asks, when will the object be at the height of 114 feet? Okay, we are going to need to set our function plus 95t plus 2 equal 114 and find out when it's going to happen. So that is the equation we're going to solve. Negative 16t squared plus 95t minus 112 equal to 0. Let's use the quadratic formula. T equals negative b is a negative 95 plus minus b squared is 95 squared minus 4ac. My a is a negative 16. My c is a negative 112. All over 2a, so it's 2 times negative 16. And that would actually give us negative 95 plus minus is going to be 1857 inside the square root. And we're going to divide by negative 32. Okay, so the positive one is going to give us the answer of 1. Let's actually round to 3 decimal places. 1.622 second. And the other one, the negative one, is going to give us the answer of 4.315 second. Okay, and you might be wondering, wait, but like, how come you have 2 positive answers? Which one are we gonna keep? Well, think about it. It's launching from 2 feet, and then it's going up and down, and it's actually asking for when it's going to be at a height of 114. Well, the highest point is actually going to be more than that. If you actually want to calculate it, let's actually do a quick calculation. Negative b over 2a in this case is negative 95 over 2 times negative 16. So it's going to be negative 95 over negative 32. So it's almost 3 seconds. So if you actually plug that in, you would see the vertex is actually higher than 114, which is why it's going to hit 114 at first, and then when it's dropping back down again, it's going to hit 114 again. So that's why we have a 1.622 second right there, and another 4.315 second right there. Since the vertex will be hit around 3 seconds-ish, it's actually 2.9 something, and that's right in the middle of these 2 numbers. So there you go. It's going to hit 114 feet twice. That's example 3. Moving on, example 4. We're standing on the top of an 80-meter tall building and launch a small object upward with a velocity of 27.44 meters per second. So let's set it up. Negative 4.9 t squared plus 27.44 t plus 80. But it's asking when will the object be at a height of 67 meters. So that means we need to set it t squared plus 27.44 t plus 80 equal to 67. Subtract it over. Negative 4.9 t squared plus 27.44 t plus 13 equal to 0. Let's solve the equation. T equals negative b is negative 27.44 plus minus e squared is 27.44 squared minus 4. My a is negative 4.9 and my c is a 13. All over 2a, so it's 2 times 4.9. We're going to have negative 27.44 plus minus. Inside the parentheses, inside the square root is going to be 1007.7536. Please keep all the digits and always use your previous answer in your calculator to get the precise answer. So that divided by negative 9.8. You should get two separate answers. One is a negative 0.439 second, and the other is 6.039 second. Of course, we're not going to keep the negative time, so our final answer is 6.039 second. Now, some of you might be like, well, how come the previous answer we got two positive answers? This one we got a negative. Well, because if you're throwing something at 80 meters already, well, that means the previous 67 meters is actually before that, which is at a negative time. And the next one, you're going to hit, let's say, 67 meters around here. And that's where you have the 6.039 second. And this is the previous one, which is a negative 0.439 second. And the vertex is right in the middle. So there you go. That's example 4. Moving on, example 5. A basketball is shot from 6 feet above ground. Let's set it up. Since it's feet, h of t equals negative 16t squared plus, the velocity is a 13 feet, 13t, and then plus 6. It is asking when it's going to be at a height of 8.2. So negative 16t squared plus 13t plus 6 equals 8.2. You can see the height is asking is higher than the initial height, so you should already know. You should actually expect two separate answers. So let's start solving. Negative 16t squared plus 16t subtracted over minus 2.2 equals 0. So t equals negative b is negative 13 plus minus 13 squared minus 4 times negative 16 times negative 2.2. All over 2 times negative 16. So you can get negative 13 plus minus, instead the square root after calculation is going to be 0.2. So the whole thing is over negative 32. You're going to get two separate answers, 0.240 second or 0.572 second, which should actually make sense because you're launching it at 6 feet per second. 6 feet as a height, and then it's going to drop back down, and it's actually asking when it's going to hit 8.2. So you actually have two different positions that's going to hit 8.2. And now, well, let's quickly calculate it. If you want to find out what is the vertex, negative b over 2a is going to be negative 13 over 2 times negative 16. So it's actually negative 13 over negative 32, which is actually less than 0.5. So that should actually make sense. This is at 0.240, and this is at 0.572. So in the middle, in between them, which is around like 0.4 something, and that's actually 13 over 32, which is the vertex. Now, I could easily ask this question and say, oh, when is going to be at a height of, let's say, 18.2 feet? Then when you plug it in, you may actually get two negative answers. That means you can't keep any of them. That tells you the ball will never be at that height. So that's example 5, and that is everything for this 4.13b lesson. Thank you.